Thank you. And thank you, Priya, for that great introduction. Although I do want to add, I've been feeling a little bit sick for the past 2 days, so excuse my voice if it sounds a bit weird. More on that later. So, today I'm going to talk to you about something very special to me. But first, I just want to make sure. Can everyone hear me?
Yes.
Yes.
Great. Okay. So, today I'm going to be talking about hijackers. Not hijackers of planes, cars, or boats. I'm talking about hijackers of the body. Now, these hijackers are what I call viruses. What everyone calls viruses. And before I get into the really serious stuff today, I want to ask you guys a little question. What did the doctor say when Justin Bieber fell ill and came to his office? Yeah?
You're cute.
No. Baby. It is. This is gonna go viral. So, now on to the more serious stuff. What are viruses? Well, viruses are tiny pieces of DNA, genetic information, set out to do a specific purpose, stored in a tiny protein capsule. Now, this capsule is very special because what it can do is it has a small tags on it to help it enter a specific type of cell. This specific type of cell recognizes this tag and is forced to allow the virus to enter inside. Once the virus enters inside, it can do two things. It can go through the lysogenic cycle or the lytic cycle. I recognize lytic as the shorter cycle because it's the little cycle. Lysogenic is obviously the longer one. So, in the lytic cycle, you have a virus that injects its DNA into another cell's DNA, and that cell immediately starts replicating copies of this virus. It replicates so many copies until the cell bursts, and the viruses go all over the place, putting their DNA into other cells. This is commonly what infections and viruses such as influenza, HIV, and other common colds use. But there's also the lysogenic cycle, and it's a much more deadly one. Now, in the lysogenic cycle, you have a smart virus that injects its DNA into a cell, but only just enough so that the cell doesn't recognize the DNA right away. So now what this cell will do is it'll keep creating copies of itself, like all cells are supposed to do through mitosis. After a while, the cell will finally recognize that small piece of DNA. Once it recognizes it, thousands of little viruses are created, and they all burst from their cells, spreading to all other places. I like to make a little analogy. Imagine your cell is like a castle, and you are the king. Now, in the lytic cycle, just imagine there's an army approaching. Your body, while the army may hit you hard at first, you'll eventually have time to prepare, because only one attacker is coming from one place, creating more attackers. In the lysogenic cycle, however, I see it more as a riot. See it as you have your kingdom perfectly defended, but from the inside, all of your people, just one day, out of the blue, decide to revolt against you. It's chaos. There's no way you could have prepared for it. Now, how does our body protect against viruses? I mean, as I've showed, these things are very dangerous. Well, again to the castle analogy. Your body has these cells called macrophages. What these do is once an attacker enters your system, it will obviously get into the cell it was trying to get into, because your body doesn't have defenses to recognize it immediately. Once it gets in, however, and starts creating more viruses, your body has these macrophages go in acting as scouts, and capturing one of the viruses and checking its tags. By checking its tags, your body now knows exactly what the virus looks like, what it feels like. Because your body now knows what the virus feels like, these macrophages, the scout cells, will go immediately to the lymphocytes and the neutrophils in your bloodstream, which are just normally patrol cells. They just patrol your blood like macrophages to make sure no attackers get in. They send all the neutrophils and the lymphocytes to the destination of the cell which is being attacked, and from there they try to fight out the battle. Usually though, viruses have become very advanced and are good at surviving. So your body sends the macrophages to specialized cells, such as B cells and killer T cells. Now these are crazy cells. Killer T cells would be like your best warriors in your army. They do the most fighting. These are probably one of the most effective ways of killing a virus. And the B cells are kind of like memory cells. They act as little baby scouts. They recognize this tag that the macrophages have given to them, and they put it into the system where for a couple of years, maybe a couple of months, your body will always be on the lookout for that tag. It's like an army came to fight you, you got them to back off, but you don't want them to come and fight you again. So you're always going to be kind of wary. Are these guys going to come back? That's what the B cells will do for you. So, after all of this, we might think viruses are terrible things. Sorry, scary things. They can do horrible things to us. But did you know viruses can actually help you? Okay, well, they can. And scientists are starting to use viruses as a new way of protecting your body against bacteria and helping people with disabilities. Now, to protect your body against bacteria, what they can use viruses to do is they use a very specific virus called a bacteriophage. Now this is the virus with the most confirmed kills in our entire planet. It has literally killed more living things than any other thing on this entire planet, even more than humans. We call ourselves the deadliest animals, but this thing is crazy. Ever since the dawn of time, it's been bacteriophages versus bacteria, constantly fighting each other, trying for survival. But the bacteriophages always have a way to adapt. Luckily, they don't attack humans, only bacteria. So, recently I stumbled upon an article. I saw this famous scientist was out exploring Australia with his wife when he contracted a really bad bacteria. Now this bacteria was eating at his lungs, at his heart. It was really damaging to him. And the scientists could not find a way to stop this bacteria, because this bacteria was a superbug. And that means it's resistant to antibiotics. Now, because this bacteria is resistant to antibiotics, even though scientists had a cure, they just couldn't stop this thing. It kept growing and growing till the man was almost on the brink of death. They had to find something and they had to use it fast. His wife was also a scientist, and she'd recently been researching on bacteriophages, which can stop bacteria. So, what the scientists did is, they enlisted help from a couple of bacteriophages that were specifically designed to target that bacteria that the man had, and the man miraculously got better. This is an amazing revelation. Who knows what we can be? We already know that our antibiotics are starting to lose their control over bacteria. Things like smallpox, influenza. You know, people used to die of the flu. Nowadays, we get the flu and it goes away in like maybe a couple of days. But those days are almost going to be over. We have to find a way to stop it. That's where the bacteriophages can come in. The other way bacteria can help us in people with disabilities, some people with disabilities like Parkinson's can use these specifically genetically modified bacteriophages to inject light-sensing proteins into their nerves near their brain, so that now, once they sense light, they can actually control the person's arms. Because of this, you may people with Parkinson's and other diseases may be able to recover from their disease fast. I chose this topic not because it was extremely that interesting to me. I've always liked bacteria a little bit more, but I chose it because it tied in with my very first speech as a student under Aarush. And I would like to thank him for everything he's done for me and everything he's done to make me a great speaker. Thank you for all you've done, Aarush. And thank you for listening.